Hello, everyone, and welcome to this mini lecture. In the previous lesson, we learned about the principles of PCB image stitching. In this session, we will learn the step-by-step procedure of PCB image stitching. By the end of this session, you are expected to achieve the following objectives. 1. Preliminary preparation. Open the MV Viewer software to acquire images. Place a PCB board. The success of subsequent tasks depends on whether a complete PCB board can be captured. If the full PCB cannot be captured during acquisition, the working distance needs to be adjusted. The current working distance has been preset, allowing for the entire PCB to be captured. Next, adjust camera parameters to acquire a clear image. Click on Common Properties and adjust values such as white balance and exposure. Once the MV Viewer software has been configured, you can proceed to KiMage software for the experimental operation. 2. Create project and configure tool group. Create a new project named PCB Board Stitching. Step 1. Create a new tool group named Homing. Each new project requires homing. Add a PLC control tool. Double-click to open the parameter interface. Check the homing setting and sequentially click Release Interruption and execute. After homing, remove the PCB board and replace it with a calibration board. Step 2. Create a new tool group named XY Calibration. Double-click to enter the tool group. Sequentially add PLC control tool, light source control tool, and camera tool. Double-click to open the light source control tool and set the backlight brightness value. Click the camera tool's run button while moving the platform directly under the camera, so the calibration board is clearly within the captured image. Determine the current photo position coordinates. Double-click to open the PLC control tool in the parameter setting interface. Check control setting, get position, and click Release Interruption and execute. Then copy the X and Y axis positions from the axis position interface and paste them into the motion settings section, clicking Release Interruption and execute. Add a circle finder tool. Double-click to open the parameter interface. Click Register Image. Frame a complete large circle in the image display area and click Execute. Add the XY calibration tool. Double-click to open the parameter interface. Select input type as distance input. Enter the radius pixel values of the circle found on the calibration board into the X pixel distance and Y pixel distance fields, and enter the actual radius value of the circle selected by the circle finder tool on the calibration board into the real distance field. Click Execute. The calibration tool group does not need to be executed continuously. Execution is only required once during the project setup stage. Add light source control tool. This light source tool is designed to adjust the brightness value of the light source to 0 after taking the photo, in order to reduce energy consumption. Once XY calibration is completed, remove the calibration board and replace it with a PCB board. Then the PCB board stitching measurement can be carried out. Since the PCB board is relatively long, 3 images are required to complete stitching and subsequent measurements. Step 3. Create a new module named PCB Stitching Main Program. Link it with the homing tool group. Double-click to open the main program interface. Create a new tool group named Image 1. Double-click to open it. Add another PLC control tool and rename it to Capture Position. Add Light Source Control tool and Camera tool. Double-click to open the Camera tool parameter interface and reference the XY calibration in the Calibration Data section. Adjust the exposure value to ensure image clarity. Click the Camera Tools Run button while using the joystick to move the platform, so the first part of the PCB board is captured. Once a suitable imaging position is found, teach the capture position. Double-click the Photo Position tool to open the parameter interface. Click Control Setting. Get Position. Release Interruption. Execute. Click Axis Position. Copy the current X-axis position. Return to the parameter interface and paste it into the Motion Settings section. Click Release Interruption. Execute. Copy the Image 1 tool group, rename it to Image 2, and connect it to Image 1. Double-click to open it. Click the Camera Tools Run button while using the joystick to move the platform along the X-axis, so the second image of the PCB board is captured. The second part of the image includes the 4 middle circles. Once a suitable imaging position is found, teach the capture position. Here, rename the Capture Position 1 tool to Capture Position 2. Double-click the Photo Position tool to open the parameter interface. Click Control Setting. Get Position. Release Interruption. Execute. Click Axis Position. Copy the current X-axis position. Return to the parameter interface and paste it into the X-axis Motion Settings section. Click the Run button on the right side of the Capture Position 2. Delete the Camera tool. Add a new one. Double-click to open the new Camera tool. Reference XY calibration in the Calibration Data section, and click Execute. Next, copy the exposure value from the Camera tool in the Image 1 tool group, and paste it into the exposure field of the Camera tool in the Image 2 tool group. Copy the Image 2 tool group, rename it to Image 3, and connect it to Image 2. Double-click to open it. Rename the Capture Position 2 tool to Capture Position 3. Click the Camera Tools Run button while using the joystick to move the platform along the X-axis, so the third image of the PCB board is captured. Once a suitable imaging position is found, teach the capture position. Double-click the Photo Position tool to open the parameter interface. Click Control Setting. Get Position. Release Interruption. Execute. Click Axis Position. Copy the current X-axis position. Return to the parameter interface and paste it into the X-axis Motion Settings section. Click Release Interruption. Execute. Delete the Camera tool. Before deleting the Camera tool, copy its exposure value. Add a new one. Double-click to open the parameters interface of New Camera tool. Paste the exposure value into the Image Settings section. In the calibration data of the basic parameter interface, reference XY calibration, and click Execute. Now that all 3 images have been captured, we'll begin image stitching. Create a new tool group named Image Stitching and connect it to Image 3. Double-click to open it. Create an image stitching tool. Double-click to open its parameter interface. In the Basic Parameters section, click to add Image 1, Image 2, and Image 3, and respectively reference the output images from the Camera tools in the Image 1, Image 2, and Image 3 tool groups within the PCB Stitching main program. Click Run. Exit the Image Stitching tool group. Click the plus button in the top left of the display area to add 3 windows. At this moment, the window is empty. Drag and drop the Camera tools from Image 1, 2, 3, and the Image Stitching tool into Windows 1, 2, 3, and 4 respectively to view the images. Set Image 1 tool group as the Start module. Run the program. After running, if only 2 stitched images appear, modify the parameters of the Image Stitching tool. Double-click to open the parameter setting, set number of columns to 3, stitching mode to soft stitching, K-match, and click Run to check if a complete PCB board is stitched. The stitching is successful. You may also rerun the entire program in the main program to regenerate a complete PLC board. Create a measurement tool group and link it to the image stitching tool group. Double-click to open the measurement tool group. Add a shape matching tool to locate specific features. Double-click to open the parameter interface of the shape matching tool and delete the previously defined search region. In the basic parameters interface, under the tool binding section, click the drop-down menu of the input image and reference the output image from the image stitching tool within the PCB stitching main program, image stitching tool group. Click the Run button on the right side of the shape matching tool. Reopen the parameter interface and click Register Image. In the display area on the right, frame the center point. Sequentially click Set Center, Create Template, and Execute. The label Model will appear in the display area. Next, proceed to measurement. First, measure the large circles. Add a circle finder tool and rename it as C11. Double-click to open the parameter interface. Click the Register Image button, frame a complete large circle in the image display area, and click Execute. There are 4 large circles in total, so 3 additional circle finder tools need to be added using the same method. Additionally, 2 small circles require the addition of 2 more circle finder tools using the same procedure. Next, measure the distances between circle centers. Add a point distance tool. Double-click to open the parameter interfaces of both the point distance tool and the circle finder tool. Drag the center coordinate of small circle 1 into the first point field and the center coordinate of small circle 2 into the second point field. Click Execute to obtain the center-to-center distance. Similarly, 4 sets of center distances can be obtained. Then, measure the lengths of the 4 edges. Before measuring, identify the coordinates of the 4 edge lines. Add a line finder tool and rename it as Length 1. Double-click to open the parameter interface. Click Register Image. Align the line with the left edge of the PCB board in the display area and click Execute to identify one edge line. Then, identify the remaining 3 lines, length 2, width 1, and width 2, using the same method. Add a line distance tool. Double-click to open the parameter interfaces of both the line distance tool and the length 1 tool. Drag the line coordinate output from length 1 into the first line input box. Open the parameter interface of length 2 and drag its line coordinate into the second input box. Click Execute to measure the length of the PCB board. Measure the width using the same method. Now measure the angles at the 4 corners. Add a line angle tool. Double-click to open the parameter interfaces of both the line angle tool and length 1 tool. Drag the line coordinate output from length 1 into the first line input box. Open the parameter interface of width 1 and drag its line coordinate into the second input box. Click Execute to measure the angle at the top left corner of the PCB board. Measure the remaining 3 corner angles using the same method. Next, measure the distances from the small circles at each corner to the edges. First, determine the center coordinates of the small circles. Add Circle Finder tool. Double-click to open the parameter interface. Click the Register Image button and frame the small circle in the image display area. Click Execute. Add 3 more circle finder tools using the same method. Begin measurement. Add a point-to-line distance tool. Double-click to open the parameter interfaces of both the point-to-line distance tool and the circle finder tool. Drag the center coordinate of circle 1 into the endpoint coordinate field, and drag the coordinate from width 1 into the line coordinate field. Click Execute to obtain the distance from the top left small circle center to the edge. Similarly, obtain the distances from the other 3 small circles to their respective edges. Exit the measurement tool group. Click the button and drag it into the display window on the right. Right-click to open the drop-down menu and select Bind Manual Bind to verify whether the attributes of the measurement tool group are correctly associated. If all associations are correct, the measured values will be displayed during program execution. Exit the PCB stitching main program. Copy the homing tool group and connect it to the PCB stitching main program. Set the first homing tool group as the start module. Run the complete process to verify the results. After execution, the measured values can be seen in the lower left display window. If any content is not recognized, enter the main program and adjust the grayscale values for the corresponding tools within the measurement tool group. Run again. All required measurements have been successfully obtained. That concludes today's lesson. As the saying goes, practice makes perfect. Please be sure to review and practice the steps of PCB image stitching after class. Thank you all for listening, and see you in the next class.